let's start to appreciate on the topic on a topic on functions here. So the first thing that we need to appreciate is the definition itself. A function basically is a mapping, right? Is a mapping where every element that is in the domain, every element that is in the domain set is mapped, right? Is mapped. We'll talk about mapping again. Is mapped to exactly one element in the range set. So there are a couple of ways that we need to probably to talk about. The part on mapping, the part on a domain, the part again on a range. So we'll talk about mapping first. So a function we are saying that is a mapping where every element in the domain is mapped to exactly one element in the range. Let's take for example that I have a function like this, a function of x. If I am writing like this means that function of x or f of x, this can be written the same way as function of x like this. It's just read the same way, f of x or a function of x. So for this series, we're gonna be calling this f of x, and we're gonna be using this notation most of the times. But even when you see this, it's still okay. It just means the same thing. Suppose that I have a function that is written in terms of x, whereby it's y. Okay, let's have it like this. F. Okay. Let's just rewrite it, whereby we're saying that x plus 3. So the function of x is defined is x plus 3 like this, right? So we're saying that any input value that you're going to be giving to this, suppose that we have our values of x are 1 and 2 and 3. If x is 1, then the value of f of x, these are my x inputs, these are going to be my f of x outputs. So, okay, sorry for that. By saying if x is 1, then we'll substitute here. We'll call that what? F of 1 like this. F of 1 is equals to 1 plus 3, which is going to be giving us f4 at the end of the day. So when x is equals to 1, f of x is equals to 4. When x is equals to 2, that's f of 2. F of 2 now is going to be equal to 2 plus 3, which is going to be giving me what? A 5. F of 3 is going to be giving me a 6. So this is the set of my input values. So we call this now the domain. So domain means the set of my input values. So if x is equals to 1, then the corresponding output is 4. If x is equals to 2, the corresponding value of f of x is going to be 5. That's the part of mapping. 1 is mapped to 4 using this function. 2 is mapped to 5 using this function. 3 is mapped again to 6 using this function. So mapping is just that we're talking about the part that a transformation that is happening to x through the function to give us a new value. So if x is equals to 1, our new value is equals to 4 because of this function. That's what we're calling mapping. So by definition, a function is a mapping where every element in this domain set is going to be giving us an exactly one value in the output set, which is the set of my range values. You get the point? So an easy way to remember this is that D is first, then R is second on the alphabet. So domain, input values, range, the output values. That's how you can actually easily remember that. So when we talk about a one-to-one function now, is a function whereby every domain element is giving us only one, is giving us a unique output. There are no two values of x in this range that are going to give me the same value of y in this sense. You get the point? The same value of f of x, I mean to say. So this is an example of a one-to-one function. Take for instance, if I have suppose f of x being defined as x squared like this, right? So we are saying if I have -1, -2, let's have 0, let's have 1, let's have 2 as my input values for x. My corresponding y value is what? X. -1 squared, that's going to be 1. -2 squared, that's going to be 4. 0 squared, that's going to be 0. 1 squared is going to be 1. It's going to be 1. So this is pointing to this. This is pointing again to this. This is pointing to this. This is also pointing to this. And this is pointing to this. So we are saying now we have two values of x that are giving me, we have two values of x, this and this, that are giving me the same value. Two different values of x that are giving me the same value. So this now is called a many to one. Many x values and more than one x value is giving me the same output value. So in this sense, -1 and 1 are giving me the same value, which is 1. -2 and 2 are giving me the same value, which is a 2. So that's why we are calling it a many to one. So a many to one function is when we have a multiple number of x coordinates of input values or of the domain that are giving me the same, that are mapping to the same value in the range set or in the set of my output values. So that's what you're calling many to one. So range, set of my output values, domain, set of my input values. So suppose that you are given a function is check this part. Some value, some functions or some expressions that are not deemed as functions. If I have something like this, right? If I have something like this, we are saying that this is not going to be treated as a function simply because that if I have a value of f of 4, f of 4 is not a function. Why? Because we are saying that the square root of 4 is equals to plus or minus 2. So 4, an input value is mapped to two different values, -2 and +2. So at the end of the day, this is not going to be treated as a function unless we're going to give a restriction on the set of input values. So as long as x is an element of real numbers, as long as this is my only domain, then this ceases to be a function unless we put a restriction to this. I hope you are able to understand this introductory video. I'm going to send a couple of questions that are pertaining functions altogether.